Welcome back, I'm Alex Bowles from LearnProgram.tv, and in this video I'll be showing you the different data types that there are within Python, or the most important ones at least anyway. So the first one we've already roughly seen is numbers. However, there's two types of number data types, and that is an integer and a float. Now if you've done any programming in other languages, you might have heard of float being called a double. It's the same thing, it's just when it has a floating decimal point. So this would be an integer. So number 42, number 50, number 120, they're all integers. But as soon as it has a decimal point, it becomes a float. And I'll show you this by just quickly doing a is equal to 50. And then I'll do type A. And I need to print that out. And inside the print, if we actually do a comma, it allows us to do another print as well. And so if we do type A, comma A, it'll allow us to see the type and then the value of that. So if we save that and run, you'll see at the bottom we get a class of integer and the value is 50. Now if I was to add 50.0, even though the actual value hasn't changed, the way it's represented is changed and it's now called a float. And a float is a decimal, is something which has a decimal point. Now there are a couple of things that you can do with float and integers which are different, which is why you might need something in particular for one way or another. But I'll go over those later on within the course. The main thing that you should know at the moment is that the two different types exist, but they do have different meanings and purposes, and also that you can convert one to the other. So for example, if we wanted one to be an integer, we'd do an int function around it. This is called typecasting, and what you'd do then is you'd type 50.0 inside there, and if you run that, you'll get an integer of 50, and that just rounds it off. It cuts off any decimal points. Even if it's 0.9, it will round it down to 50 because it doesn't take into effect rounding. If you wanted to do that, you'd have to use the function round, which would then, there you go, it would now run it and convert that to 51 because it's closer to 51 than 50. So there are math functions available which we will be covering later on again in the course. But because you can do the typecasting of integer, that also means you can do the typecasting of float. So if you were to have 50.9 and run that, it would stay at 50.9. If you were to get rid of those two digits, it would come up as 50.0. So now that you can typecast between float and integer, you can control the way in which the application runs, which is quite a useful thing to have. Now the next type of data that we're going to be using is also is called a string. And so the way you represent a string is by using either two single quotes, one at the beginning, one at the end, or two double quotes, one at the beginning, one at the end. Now it must be the same type of quote at the beginning and at the end so that it can tell what the actual content between it is. And so this is a string. And as you can see, if I was to run this, you get a class of str which stands for string, and the output is this is a string. Now before, I mentioned that you need to use one of each quote at each end. However, there is a way in which you can do triple quotes, which allows you to do multi-line text. And so this is a string. Would print that out over 3 lines. So there you can see this is a string as a class. If I just remove the type from there, it recognises it stays as a string, even though you're using a different way of representing it, it's still a string. You'll notice that it has this tab in from the side, and that is because it follows the exact formatting that it has within this string area here. But also you'll notice it has an extra line at the top, which you might not want. The way that you can get rid of that is something called escaping. What you do is you add a backslash as the last character on the string, on the first line, or the last character on any line. It'll have the same effect. And what it does is it escapes the actual character that follows it. And there is a character here which is invisible, and it's the paragraph character, which it looks sort of like a backwards P with two lines going down. That's the character which is invisible, but it is saved there, and that's what makes it have a new line. And so, likewise, if I was to put a backslash on here and run this, we would get this is a string on the same line. So as you can see, all it does is control or escape certain characters. Now, you can do this with either single or double quotes, and again, it must be the same at the beginning and the end, although it is much cleaner to look at to use single quotes and double quotes, because that just looks more untidy because there's more lines going down. Okay, the next thing that we're going to have to look at is the fact that you can escape multiple different things. I'll go back to using single line strings for now. So this is a string. If I wanted to have a new line, what you have to do is /n. And what /n is a special escaped character which refers to making a new line, the invisible paragraph sign. And so when you run this, you get this is a string. But if you were to actually want to have /n within your content, you need to convert it into a raw string, because obviously this is being processed as being a special character, but there might be an occasion when you want to actually output /n. The way you do that is to convert it into a raw string by putting an R in front of it. And now you'll get this is R. Sorry, that's not right. There we go. So you need to add another backslash to it, and that will convert it into a raw escaped character. And what you do there is you have you now get the output of /n, and what that backward slash there does is it escapes the one after it. So you have two backward slashes will escape the backward slash, and that backward slash no longer escapes the n. So now you end up with just /n. If you're confused by that, don't worry too much. It's a simple sort of concept, and you will learn more about it as we progress throughout the course. Okay, there is another very useful thing which you use within a string, and that is to add extra data to it. So we're going to add another variable, and we're going to call this one just put hello within it. And what you'll see is this is the old way of doing it, and you use the %s, and afterwards you put a % and then the actual letter. So I'll change that letter to make it more obvious. I'll call that B. And if you run this, you'll see this is hello a string, which is what you'd expect to happen, because that %s there stands for a string input, and %b just shows that we're using what that % is, and we're using the variable b. The % sign is just a way to reference that we are finding an input from somewhere else within the script, another variable. There is another use for percentage, which we'll get into when we go into arithmetic operators, which is something called the modulus function, but we'll move on to that later on when we get more back into numbers again. But as I mentioned, this is the old way of doing it, and there is a much newer way, which is within 3.2, or it might come in 3.1, but it came in with version 3 something, and it's the way in which Python's heading towards, and this way is kind of obsolete, and it's going to be removed within the next version or two. So it's probably best not to use this method, although I just showed you it just so you can see the difference between the old and the new, because if you see any code online, you will see it most likely the old method, which is this method. The new, it's worth noting that, say if I was to replace this with an I, then that would put in an integer, and so on. And an F for float, and a B for boolean, which I'll cover in a second, and D for a dictionary, which I'll cover again in a few minutes. So the new way of doing this is what you do is you add curly braces. The curly braces are next to the return key, and you have to do shift and then open and close it. And what you have to do now is format, which is just a function which appends something or inserts something into the string wherever the curly brackets are. And if we were to run this now, you'll see we get the exact same output. However, this is the new way of doing it, and this is the way in which you should be doing it, inserting data into a string from now on. The way in which this would be considered useful is if you were taking input from a user, then you could output a certain value from a function, or you could output a certain value based on what they put. So if they were to insert their name, then for example, I would use the name Alex, and an application might say something like welcome, and what that would do there is it would now say welcome Alex, for example. So that is the sort of idea behind it, and that is what we will be using it for most of the time. Now, there's also another couple of data types which are sort of related to an array, which, if you don't know what an array is, don't worry about it too much. It's called a list in Python, which sort of describes it more closely to what it actually is. And so there's two types of lists. One's called a tuple and one's called a list. And a tuple you define using the parentheses, and how you define it is by putting any variable name is equal to and then open and close the brackets. Then you just do 1, 2, 3, 4, 5. And to separate each value, just put a comma between it. And what you'll see is I'll just do print type x, and there you'll see that it's the class of a tuple, and you get the values of 1, 2, 3, 4, and 5. Now there is a function called append, where you can append a value to a list. However, with a tuple, it doesn't exist because a tuple cannot be modified. It is declared once, and then that is all it can be kept at. So it was similar to a constant, really. However, if you wanted to change something, what you would use is you would use something called a list, which is declared by using square brackets. And if you were to run this, you'd get a class of a list and square brackets of 1, 2, 3, 4, and 5. Now, if we were to add back in that append function, you'll now get 1, 2, 3, 4, 5, and 6. So there's different uses between the two, but the main difference is that one of them can be modified and one can't. If you can't modify something, then you're less likely to make a mistake with it. So if you don't need to modify something, it's better to use a tuple than it is to use a list, because using a tuple, if you were to try and modify it, and when you weren't meant to, for example, then it would throw that error and you'd be able to find out where your problem was. Whereas with a list, as you see, because it allows you to insert and append and prepend and so on, it would allow you to continue without knowing that you made a mistake somewhere, in which case it might actually break your application, for example. Okay, and now that we've covered both of list and both the list and the tuples, there are a couple of things which are special with lists which you can't do within a tuple, and that is to declare a certain memory location within, or certain index within the list, and you do that by using the square brackets and an index value, and the index value here is 3. However, we inserted a number 2, and if you look up here, number 3 is the third one across, and the reason for that is that a list is indexed starting at 0. So this has the index of 0, this has an index of 1, and this here has an index of 2. We're referencing the index of 2, so that's why we get the value of 3 back. The next thing in which you may find useful, and we'll be covering later on, is something called, it's where you can select a value within a range. So if I was to go 2 to 4, you'd get these values. You'd get 3 and 4. Now the reason why we don't get, because remember that indexes start as 0, it goes 0, 1, 2, so we select that value. That's the second one, and then we're going towards 4. However, 3 and 4, you'd expect it to return the value 3, 4, 5. However, it only turns to 3, 4. And the reason for that is that the final actual number doesn't get found. If we were to change that value there to 5, then it would select it and it would work. And also there is a method in which you remove the final number and it'll select from 2 towards the end. And if I was to change that to 4 and remove the first number, it would select things up until the 4th index or the 3rd index. So from there, we'll be covering this in more detail later on, and I'll be explaining certain uses for this construction idea. However, that is a very useful and powerful tool whilst using listings. The next thing that we have is something called a dictionary, which, if you have programmed before, is similar to an associative array. And the way you declare these is by using curly brackets. So a curly open and closed bracket would declare it as being a dictionary. Now, the idea of a dictionary is that you have a key which you can define and a value which you match it to. So something like this would be a common idea for an array or for a dictionary, depending on what you want to call it. So if we were to save that and run, you'd see we get the class of a dict, which is a dictionary, and we get the values of 2 and 1. Now you'll notice that these aren't actually in the same value as what they are, or the same order in which they are when they are declared. And the reason for that is because it's a hashed table, and so the actual values don't get stored the same way in which they do. In which they get declared. They get stored in the order in which it is more suitable for them to be hashed in. It's a memory order sort of thing. So I won't go and try and explain how it orders them. I'll just explain that there are ways to sort it, which we'll be covering later on when we do iterations or looping. But if you were to have a dictionary and you can declare it using this sort of idea, however, you'll notice that we have to have quotes around the strings, and we don't have quotes around numbers. That's a very important thing. If you have a quote around a number, it stays as a number. It gets converted to a string. So, and also these can be changed around. But the one thing that you need to remember with dictionaries is that this is the key, or we also call that the index sometimes. And this here is the value, which is related to the key. So I could change this around and put that as being 5. It makes no logical sense to do that in this idea. However, if we were to have something different, say call this ID and this one name, I can change this to be Alex and it would work. So when you're using dictionaries as an associative array, the data type doesn't have to be the same within the actual array. And the same with listings, it doesn't have to be the same type within the list. Now, you may be wondering what the point of having a list is if you can have an associative array. And the reason why you'd use a list is because it's actually considered faster to run, because it gets returned in the same order in which it gets declared at. So if you knew a certain location on where something was, you'd use a list because then you could declare what that location is. Whereas using this sort of idea, you'd need to run extra functions to find out the actual location of a storage, of a piece of information that is stored. Okay, there's also another way in which you can declare a dictionary, and I'll just write that, and that is using the dict function. And the way that you do that is 1 is equal to 1, 2 is equal to 2, and I'll just leave it at that. What you can see here, I'll just change this as well. Okay, if we save that now and run that, you'll notice that we get the same class. It's another way of declaring it. It's just a more readable way of declaring it. This can be put over multiple lines should you find it easier to do that. However, you'll also notice that the keys no longer need to have quotes around them. The key gets a quote around it automatically, depending on obviously the data type. It gets recognised as being either an integer or a string, basically, and the value does still need a quote around it. However, this is considerably easier to actually write because you need to hit the quote key considerably less often, which makes it faster and easier to write. It also makes it easier to recognise as well because it has the function of dict rather than just curly brackets. The final thing in which we have to talk about is something called a boolean. Now, a boolean is either true or false. That is the two values of a boolean. So if we have a boolean equal to false, then you'll notice that the class is bool and the value is false, as you'd expect. So false and also just true are both keywords which are used very, very often within programming languages, and especially Python. You use them all the time without even knowing it usually. For example, if I was to declare two variables and have it as 0 and 1, then if I was to do if A is equal to B, actually I don't need these. Okay, if A is equal to B, then print and if we do that, you'll see that we get the boolean of true. Now, what you see here is that we're doing a check of A is equal to B. Now, A is not equal to B, and so what we're getting is the output here, which we can see if we do else and print false. Now you'll see that we get the value of false, and the reason for that is because we have A is not equal to B, because A is equal to 0 and B is equal to 1. I should note that you can declare multiple variables on each line by separating by commas, and just make sure that you have the same number of values on the other side separated by commas. So if I wanted to declare C, then I could declare that as being number 2 there, and that would work just the same way. So having true or false is used very often within Python and other languages, but usually without even being recognised. The way in which they are used is that the value is being checked as to whether something is equal to something. If you're doing a double equals, which is to check whether the values are the same. If you use a single equal sign, that is to add something, to make something equal to something. When using double equals, that is to check whether something is equal to something. So there is a big difference between single and double equal signs, and if you used a single equal sign within here, it wouldn't work. It would just not run properly. So what you need to recognise within this is that even though you're not seeing the word true at all, it is a boolean expression. It is checking whether or not something is true or false, depending on what keywords you're using. I'll get into using logical operators later on within the course. However, what you will see is that this sort of idea is happening quite often, and this is just a boolean check. So if something doesn't happen as you'd expect it to, there are ways to debug it, which again I'll be covering later on in the course. Thank you for watching. This has been a fairly long video, which I apologise for. However, I'm sure that whilst it's taken a long time to get this far and it doesn't feel like you've done much, understanding this will make the rest of the course considerably easier to understand. Because once you understand data types, you'll understand how things flow together within Python. So if you are slightly confused, I would recommend that you rewatch this video or the bits in which you're confused within this video, and it will explain things to you, and hopefully once you understand them, it will help you understand the rest of the course. If you do find this sort of slightly difficult to get your hands around, to get your mind around and to understand, watching the rest of the course might also explain this part, so it's up to you how you want to learn this. However, I would recommend that you understand this fundamental concept of programming before you understand the rest of the course. So I'm Alex Babs from LearnToProgram.tv, and thank you for watching.